You are on YouTube now, yes.
Oh, I am again.
What happens with this number here? The bigger you make it here, the larger the taller the graph gets. All the points are being expanded. I mean, if you make the numbers too big, you can't see them here. But if we stick with the 2 or close to 2, to my skills at using this pen here, all of those points now where this was a 2, now it's a 4, right? All the y values are twice as tall. Even right here, instead of the starting value being 1, starting value is 2. As you expand this now, that's not what we want. Okay, as you expand this one now, all the points are twice as big, right? This was 1, now it's 3 times as big. That's 2, now it's 3 times as big. If you make it smaller than 1, it's shorter, right? There's half as much. If you make it negative, it's just exactly what you expected before. It's also a reflection. Okay, it reflects it below and changes it. This is a vertical compression or a vertical expansion, right? If you put a 2 in front, it's going to be a vertical expansion. If you put a negative 2 in front, it's going to be a vertical reflection and a vertical expansion. The y values are twice as big, and it's reflected. So if you want to use some of the right language here, this is a vertical expansion, which you can probably abbreviate here. Vertical expansion by a factor of what? 200. It's going to be 200 times as tall. This one here is going to be a vertical compression by a factor of, by what? 1/10. It's going to be 1/10 as tall. All the y values are going to be 1/10 as big. The other one's up here. What did you say this yellow one was? Just so we're using the right language here. It moves 2 to the right. You say it's a horizontal translation. Translation in math means a shift sideways or up and down. 2 to the right. And then this one outside of this function, changes outside of the function or after the function are vertical changes. Changes inside of the function are going to be horizontal changes. This 3 to the power of x minus 2, on the calculator you'd write it like that. It's inside the brackets, so it's a horizontal change. Whereas this one, 0.5 to the power of x and then plus 4, it's outside of the function. So it's a vertical change. This is a vertical translation. Translation of 4. Which way does it go? 4 up, right? Up 4. You can answer these 2 down below, I'm sure. Down 3. And then how is this changed? This has this number in front here. That actually does 2 changes, right? It is a vertical reflection. Now you should put down what axis it's over, what line it's reflected over. Go back to this for a second. When I reflected this, so what I had there was this was a 4. This was nothing actually. Oh yeah, that didn't matter right now. This was a negative 4. What 2 changes have happened there? It's been expanded and reflected. It's been reflected down below and expanded. You could think about it as reflecting first and then expanding, or you could think about it as expanding and then reflecting it over. But that negative 4 makes 2 changes. It's reflected over the line y equals 0, the x-axis. That's like where the mirror is. So when you talk about a reflection, you should say over the x-axis, or in other words, over y equals 0. And then it's also a vertical expansion by a factor of 4. All right. Doesn't E go one to the left? Oh, it does. Yeah, of course. There are two transformations there. I forgot that after I highlight it and everything. This is a horizontal translation. One to the left. Thank you for pointing that out. Again, later in the year we're going to look at a general transformations unit, but right now we're just looking at specifically to exponential functions. The rest of this stuff here, actually drawing some graphs, I would like you to try and do that. If you're trying to draw the graph of this, think about this cloud over here, what's been changed, and how that affects the graph. What you could do is just kind of shift your place to a new place. This is these dots that are on here. These dots are intended to give you what 2 to the x looks like. You can think about what happens to each of those points with that transformation and how to draw it. Explain how transformations can be used to draw the graph. Here's another one that's been transformed. We're doing single transformations at the beginning. This is review of quadratics. This is to expand it to this. Hopefully I've given you enough information to kind of draw some of these graphs. Then I would like you to look at summarizing the ideas. What happens as you change A? Be specific about this. What happens as you change the base is different, right? This is the basic function, this B in here. That's what we looked at first before lunch. Which of those changes affected the asymptote, which affected the y-intercept? All those things are for you to investigate right now. Incidentally, if you want to use this software, you can use any of these computers in here and play around with it if you want to investigate it that way. I don't really care how you investigate it, if you draw the graphs here, or if you go and just play around with the software. This software is on my website. If you go there, it opens a window that pops up and you can use it. If you ever want a graphing program, there's the link that I said here. Can you get started on that, please? We're going to try and finish this tutorial, I would say. Would be a good plan for today, and work on practice from all of these things. I don't want to get into beyond this.